So in one of our previous lessons, we learned about things called Maclaurin and Taylor polynomials. And in this lesson, I'm extending that by a bit. Instead of stopping at a finite number of terms and calling it a Maclaurin polynomial, we're now going to look at a Maclaurin series, or a Taylor series, which just means taking those polynomials and sort of writing them down infinitely. I'm going to go through one example the old way, and then I'm going to show you sort of the new, slick way that we're going to do things. So the one example of the old way that I want to use is for us to find a power series about x equals 0, so find a Maclaurin series for e to the x. So as you recall, the way that we did this back in the day is we would start with, f of x is e to the x, and f prime of x is, the derivative of that is e to the x, and f double prime of x is e to the x, and so on. And note, I'm not telling you here how many terms because I want the whole thing. So I'm going to go ahead and go to the third derivative. So this is e to the x. Then for each one of these things, I'm supposed to plug in my center, right? So over here, I'm supposed to plug in f of 0 is e to the 0, which is 1. And then f prime of 0 is also 1, and f double prime of 0 is 1, and f triple prime of 0 is 1. And so we can see a pattern here. It seems pretty clear that all of these are just going to be 1 as we go down, right? So now that I have that, I can say that e to the x, my function, is equal to, and we can write out the power series, right? The first term was supposed to be the value of the function, which is 1. Right? Then we had plus. Now I'm supposed to do f prime, the first derivative, which was 1. So I've got 1 times x. Technically it's x minus 0 because of the center, but I'm just going to go with x. Plus the next one is 1 over 2 factorial. That 1 coming from here, of course. 1 over 2 factorial times x squared. The next being 1 over 3 factorial. X to the third. I mean, I'd imagine we can guess what the next one's. I mean, even though I didn't do the fourth derivative, we know this next one because of the pattern here is going to be 1. So the next one would be 1 over 4 factorial x to the fourth. For that matter, we can probably guess when you get to the nth term, it's going to be 1 on top, n factorial on the bottom, x to the nth. And that, I mean, this is an infinite series. It's actually going to go on forever, right? So we can simplify this a little bit and say that e to the x is 1 plus x squared over 2 factorial plus x to the third over 3 factorial plus plus x to the nth over n factorial, and then actually plus and again, because this is infinitely long, right? A shorter way to do it, I suppose, would be to use sigma notation and say that e to the x is the sum from 0 to infinity of this nth term, of x to the nth over n factorial. So this was the long way, right? The way that we did this was by taking multiple derivatives, evaluating at all the values, plugging those things into this long formula, and then sort of noticing the pattern so that we can make this statement about what e to the x is. Now the good news I'm going to give you is that I'm not really going to ask you to do that again. The whole point of today's lesson is about shortcuts. So what I am going to ask you to do today is I'm going to ask you to memorize that. You need to know that that is e to the x. And that needs to be like without any doubt at all. One other thing that we need to know is we need to know what the interval of convergence is. So I left this blank space here where we can write the interval of convergence. I'm going to go ahead and tell you, and then I'll show you, but just so we can fit this all on the screen. The interval of convergence for this one is actually from negative infinity to infinity, which is actually kind of mind-blowing in and of itself. It means that if you were to graph e to the x and then actually write this down forever, this infinite polynomial thing would actually be the same as e to the x, which I don't know, that's just astounding to me, and it's magical as far as I'm concerned. if you want proof that that's the interval of convergence, think about how you would do it. This thing right here is telling you what the series is. We just need to perform a test on that. In fact, this is a great thing for you to try on your own. If you want to pause the video and just try for a few minutes, apply a test to that. Figure out what test you would use and see what it is. I'll go ahead and walk through that for you. I'm going to do the root test. I'm sorry, I take that back. I'm going to do the ratio test because of the factorial. The ratio test. So this is going to be the limit as n approaches infinity of x to the n plus 1 over n plus 1 factorial times n factorial over x to the nth. And the reality is I need this to be less than 1. So I have the limit as n approaches infinity of x over n plus 1. I need that to be less than 1. As n approaches infinity, this is going to turn, like, it doesn't matter what x is. X is finite, it's a constant, which means this thing's going to turn into 0. So is 0 less than 1? It absolutely is. And it's less than 1 regardless of what x is. That means this thing converges for everything. In other words, it has an infinite interval of convergence. Right? So I'm getting close to bringing this first video to a close. This is one common Maclaurin series that you need to memorize. You need to memorize, like it needs to be on the front of your brain. There's going to be 3 of them today, right in the front of your brain, that e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and so on. Right? So memorize that. I told you that there were 2 more of those coming, and so here they are. Right? You need to memorize a Maclaurin series for sine x and a Maclaurin series for cosine x. And they're both actually pretty easy to memorize. Think about it this way. Don't we know that sine is an odd function? You should know that. If you don't, talk to me about it in class. It is an odd function. And so that's represented by the fact that the power series is entirely made up of odd terms. Sorry, that's really close to the top of the screen there. X to the 5th over 5 factorial minus x to the 7th over 7 factorial. And the nth term of this one, so plus dot 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 plus, you're going to have negative 1 to the n plus 1 x. No, actually, I don't want to do that one. X to the 2n. I have to do this carefully. I'm calling this the 0th term. So when you plug in 0 for n, negative 1 to the 0 is positive. That's why this is positive. And if I'm plugging in 0 here, this will have to be 2n plus 1 over 2n plus 1 factorial. So that's the Maclaurin series for sine x. The nth term is a little bit hard to memorize, but just knowing that this is all of the odd parts of the e to the x up above and that it alternates is the good way to remember that, I think. Cosine x, similarly, remember that cosine x is an even function. Even function. So, I mean, you could potentially guess what this one's going to be. It's going to be 1, which I know is odd, but think about it as being 1x to the 0, minus x squared over 2 factorial, plus x to the 4th over 4 factorial, minus x to the 6th over 6 factorial, with the nth term being negative 1 to the n, x to the 2n, all over 2n factorial. So those are the 3 functions you need to memorize. We need to memorize that e to the x is all of the powers, the 0th power, 1st, 2nd, 3rd, 4th, 5th, and they're all positive, right? And it has an infinite interval of convergence. We need to memorize that sine x, because it's an odd function, has all of the odd powers of x divided by the odd factorials. I'm a little bit short on space here, but I think I can fit it in. Both of these have an interval of convergence that is infinite. I'm not going to take the time to show that now. If you really want to know, you can confirm it for yourself. use a test, probably the ratio test on either one of these things, and you'll find that they have an infinite interval of convergence. So we said sine has all the odd powers, cosine has all of the even powers, and that's that. You're going to want to memorize those, and you'll really see why in the next video. I hope in the next video to really impress on you how amazing it is when we have these things memorized. So I will see you in the next video.